Good morning, good afternoon, good evening to you wherever you are in the world. I'm Peter Marshall, a technology evangelist at Imply, and I'd like to offer you all a very warm welcome to this third session of the day with Jeremy Woolfall, a principal engineer at Target. This is only the second Druid Summit, and it's wonderful to know that more than 800 people have registered to hear from our fellow community members across the world today. Although you'll be on mute throughout the session, you can still use the Q&A section of the Zoom webinar panel to pose questions that we'll pick up at the end of the session. And any that we don't have time to cover today will be followed up in a blog post. There will be live tweeting throughout, so be sure to follow us on Twitter, and links to the full presentation and the accompanying slides will be sent following the session. So hot on the heels of Reagan Jolly from Traffic Guard, I cordially introduce you all to Jeremy Woolfall, the principal engineer at Target. Here he leads the development of data products and platforms encompassing data from all parts of the organization. Jeremy, we're all looking forward to hearing from you today as you present building an enterprise-scale dashboarding analytics platform powered by the capabilities of Druid. So over to you.
All right. Thank you, Peter. And welcome, everybody. Thanks for joining. Thanks for inviting us to share part of our story here. And special thanks to Imply, too. This is a great event. It was a great event when we did this earlier in the spring. There's been some great sessions today. So super excited for the rest of the summit today. So today I want to talk about our journey building what we call an enterprise analytic platform and how Druid has really become the secret sauce that fuels it. So as we start, first, a little bit about Target. For folks based in the US, you're probably familiar with Target, but just in case, Target is a US-based retailer specialized in selling groceries and general merchandise. It's a brick and mortar stores, about 1,800 of them spread across the country. In addition to brick and mortar sales, we have a Target.com, which is a large e-commerce site. Globally, we have about 300 or so team members, 300,000 team members, excuse me. And that's spread across folks working in the stores and our distribution centers and also HQ folks around the globe. And then lastly, work with a ton of different business partners, suppliers and such, pretty much all around the globe. So as we begin, I guess let's define what we mean by enterprise analytics platform. So what is it, right? It's a big word. So historically, when we were talking about analytics, this is what people typically were referring to, right? You would take data that maybe existed in a relational database. You'd ETL that into a data warehouse, probably a relational database itself, maybe one of the MPP varieties, do some processing and present some data, and then offer reporting tools and SQL tools over the top of that. And those are the ways that the users interacted with that data. Fast forward to today, right, we have way more data. We have way more varieties of data, much higher velocities and volumes and all the V's. And what you typically see is people throwing this into some sort of a data lake-like solution. Right, a lot of folks use Hadoop. And then we clean that up and again kind of do that same type of ETL-ish, where we take build layers of data over the top of it into something that's kind of that certified, that gold data set. And what we do with this analytics platform is we give people the ability to use that data. So what's the purpose? Right? Let's take and make sure that data can be consumed, right, in a high performance, easy to use way. Very likely, we're making that available to non-technical users, right? Folks that are maybe marginally good at SQL, but they're very, very well versed in business. The enterprise portion of this, right? We don't want to limit this to a single domain. This isn't just a marketing tool or a merchandising tool, right? This is every area of the business that can take advantage of this platform. And then what we really think of it as a cache or maybe a copy of a place that we put our most valued data sets. So that's what the platform is. The question is, there's a lot of these out there, right? There's a lot of things that sort of fit in this niche. And why would we custom build a platform? So, right, there's no shortage of available options. There's tons of vendor products out there that have been well established for decades. There's an expanding open source market here. Every day there's something new, and there's some really, really good open source tools here. So why custom build? So when we started this, we decided to maybe take a step back and just decide, what do we want out of an analytics platform? And we centered around 3 main principles or tenets. First is speed, and specifically sort of speed to market. And what this means is a place to enable self-service development, self-service data ingestion, self-service query answering, right? The idea here is, can we equip a business user with a tool where they can have an idea of a business question that they want to be able to ask and get it answered within minutes or maybe hours, right? And not days or weeks or with IT support, right? Insight to idea, or idea to insight. Right? We want a platform that can keep up with those users as they ask more and more detailed questions of this data. And then once they've actually found something useful, can they share it? Right? Can the person next to them also consume that same data quickly and easily? Second principle, discovery, right? Collaboration, the ability to ingest data really, really easy and intuitive manner. Allow users to explore some of this analytical ready data, and then provide insights where they need them. And this is a really important key. This isn't just a place where you log into the reporting platform and get your data. We want to be able to take that data and put it into a place where users are actually taking action on the data, on the insights that they surface. Can we embed some of this data inside a planning tool or a purchasing tool or a mobile app? So that was super important to us. And then lastly, scalability. Right? Target is a big place. We have lots of team members, and we've got lots of business partners that we work with. We want every one of them to be able to use this platform, right? Can we respond to surges in demand and do that in a cost-effective manner? So those are the really sort of key things that we centered on when we decided to build this thing. So here's what we built. This is what we consider our platform. Fairly simple architecture stack. And what you'll see is, right, data being ingested into Druid. Like I said, we do that in a self-service way, and we'll talk about that in a bit. Not only is it coming from Hadoop, might be coming from other relational databases. Might still be coming from Kafka, right? That's a super powerful feature of Druid and feature of this platform. So, right, layers, or the pieces. Druid's obviously where we put our business data, right? Whether that's sales, whether that's planning, whether that's HR related data, that's where we put it. At the top of the stack, this is our sort of interface to the platform. This is what users see. This is where they get to work through a tool to author what eventually becomes a query. In the middle, this is sort of where a lot of the magic happens. This is our query generation engine. Right? We can take what a user has authored and translate that into Druid queries. This is also a place that we can enforce things like security, some guardrails around the system, et cetera. And then lastly, there's a little metadata database, keeping track of some of the various objects and state that we've got in this platform. A couple other details here. We do allow this idea of bring your own database. So it is possible to wire up a Postgres database into this and use it sort of the same as you would use Druid. And then, like we said, one of the real key features here is you don't have to use our platform's user interface. You can, right? And we have tens of thousands of users that do, but we want to be able to bring this into back office applications, mobile apps in my pocket, right? Even we have external partners that will take this data surfaced from Druid and bury it in their own applications. So why Druid, right? How do we settle on Druid to sort of power this platform? In fact, this is where we started, right? We almost dismissed Druid. Druid is just a time series database. Right? As we sort of thought more about this, we thought, well, yeah, maybe that's true. And I don't think that really is true anymore. But at the time, this is kind of where Druid was positioned. But what we realized is almost all data can be time series. Right? Almost everything of interest has a time aspect to it. And as we saw in a session earlier this morning, anything that doesn't have an interesting time series aspect to it can be faked out, right? Put a timestamp on it. Once you get past that, then what makes Druid a really good choice, right? We all know Druid's fast. We saw benchmarks from Gian this morning. Druid is fast. It does things that are really, really common in the analytics space, right? Aggregating low-level data, summarizing it into something meaningful, really good at filtering. One of the things we liked about it is horizontally scalable. You want a query to go faster? Add hardware. You want to be able to add more users and run more parallel queries? Add hardware, right? You want to be able to add more data? Add hardware. So love the fact that it was horizontally scalable. You can write some super sophisticated operations, right? You can write a lot of complex aggregations, filtered aggregation, et cetera. The community around it is awesome. Documentation's fantastic. There's a super active community building new features all the time. And lastly, it's fast. Right? That was important. So quick look at our Druid cluster. When we started this, we started with a couple of VMs that we had lying around and glued them together, and that was our first cluster. Today, it's definitely grown significantly. So we have we run an on-prem cluster with bare metal servers, and as of last week, now running Druid 18. Node count, hundreds of nodes, multiple brokers, and a load balance configuration. I guess a note about the node count here. These are beefy nodes, right? You can see that tens of thousands of vCores, hundreds of terabytes of RAM. So yeah, while our node counts are in the hundreds, this is a sizable cluster. Putting it all together is HDFS on the back, so that's our deep store, and then MySQL for the metadata storage. All told, it adds up to over a petabyte of storage that we can use when we factor in RAM plus SSD, and we're starting to use it. So we have 3,500 data sources in this platform right now, and that added up, that's about 3 trillion rows of data that we put in there. Not all data sources are the same, and so if we just do a quick analysis, right? Got to have a pie chart in an analytics presentation. Quick analysis, right? Most of the data is probably what this community would consider tiny, right? Under 1 billion rows, right? About 5 to 10% of those data sets are in sort of the sizable range where we're starting to get into tens of billions or hundreds of billions of rows. So while the data source count looks very high, the areas of interest tend to be sort of in those small yellow and orange slices. So any conversation about using Druid as a backend for this, especially as you come out of what used to be sort of the legacy BI stack, quickly turns into the idea that Druid can't do joins. Right? And so we know that this isn't true. Right? This was true a few years ago, maybe. We know this isn't true now. But it's okay. What it actually did is it forced folks to have to think about data a little bit differently. Right? You didn't load in your star schema, Ralph Kimball style data sets anymore. You actually did bring analytics ready data to the platform. Analytics ready, denormalized, maybe pre-joined, right? You think a little bit ahead about what's going to be your filtering metrics or your filtering dimensions. What types of metrics are you going to want to be able to do? And so, it forced folks to do a little bit of data preparation up front as they're ingesting into the platform. And then this took us a long ways. We survived this way for a while, but eventually we did get to the point that we needed to do some joins, or join-like things. And we're going to drill into these. So 2 super key features for us the ability to do unions and lookups in Druid. So unions, right? Unions are the way that we do fact-to-fact joins. Fact-to-fact joins are, let's back up. So unions are a native feature of Druid. For anyone that's not aware, you can basically, as a data source list, when you're writing a query, you can list a bunch of data sources in there. So let's look at an example quick. Here's a common query that users would like to be able to do with a platform like with a platform like this. Right, sales date and location. And what I want to do is I want to compare sales to the sales forecast. Right. This is, this would be something that likely would be loaded into a platform like this as two separate tables. Very likely sales and sales forecasts come from different platforms, probably loaded at different frequencies. And the cost of pre-joining this would be fairly expensive. Instead, what we can do is ingest it as two different data sources, but with some common attributes. So, right, everything's got a date, that's fine. Ingested it with common location attributes. So if you've got a location number or a state or a zip code, make sure it's common. Make sure that the names are the same and everything else. Same with items. And then, on that data set, put in the metrics that are useful. And what it allows you to do then is sort of run a union and simulate what it would be like to join sales table and sales forecast. This is a really, really powerful feature for us. We use it all the time. And in fact, we've pushed on this a little bit to the point that we can also put in inventory data, or maybe something about ordering data. We can do something crazy and layer in weather data or demographic data, maybe even shipping type data. And this all gets bundled as, to a user's perspective, something that looks like a single data set. They can operate as if it's one common data set. So keys to being successful with this. It takes a tremendous amount of data architecture discipline. Simply said, your columns need to match. Anything that you expect to be a common quote unquote join key here need to match. Need to match in names, need to match in values. And then there's some optimization you maybe want to apply. We lump this together to make it look like one data set, but we don't want to query it as if against every data set every time. We do want to be selective to make sure that we're only using the data sets that need to participate in the query. And that's really for performance and efficiency reasons. So unions are really good. They help us to relate multiple facts together, but they don't fix the normalization problem or the denormalization problem. Right? Analytics ready data is really good for performance, but it does come at a really big cost. And that is the need to potentially restate data. So here's an example, right? This is common in anyone that's got, that sells a variety of products. There's always a hierarchy of products that describe, the areas of responsibility, perhaps. So, take a quick, simple example. We've got products like M&Ms, products like Smarties, and they all roll up to some sort of a category, maybe called candy. Right? And maybe this is a sales table, but maybe it could also be a table about inventory or a table about what's being ordered. Billions of rows. And if at some point in the evolution of the business, we decide we actually want to analyze that by something else, right? Maybe that category, maybe we're going to split M&Ms out into a category called chocolates instead of candy. We would need to actually either restate all this data or do something else clever. Another example, groupings of products. So not only do we have a custom or a standard product category hierarchy, but we offer the ability to put products into just groups. Maybe this is for marketing purposes or inventory management purposes. But what it says is, maybe we want to run a back to college campaign and put M&Ms and Smarties inside that campaign. Maybe it's a different campaign that's just movie night, right? And that includes just a subset of those products. What this looks like is many to many. And many-to-many is really, really tough to do, specifically in a system that isn't a relational style database. These relationships can change pretty frequently. And so sort of problematic when it comes to needing to restate this data. So we sort of settled on the idea that we weren't going to be able to rely on denormalized data all the time. So we looked into Druid's lookup capability. Druid offers some lookup capability that allows you to have kind of a dimension style, a key map style lookup here. We looked at it, worked on it for a while, but sort of found two main problems. We've got some really large dimension lookup tables, right? Tables that are in the order of millions. And then, like we said, we need to be able to support many-to-many. And so those two things were difficult. And so what we ended up doing is creating a custom lookup solution, sort of inspired by the way Druid does it, but takes advantage of some key features that Druid does. Druid's fast. We could actually get away with running a bunch of queries and maybe even some sequentially, and it's fast enough for that to still be tolerable. It's really good at filtering, even if we pass it a crazy long list of items, right, in an in clause. So let's look at this a little bit detail. So taking that previous structure and normalizing it, it might look like the table on the left, right? I just have product in there. I've removed category or grouping, and then I load a second data set that is a product to grouping map. So here's a query that maybe a user would want to ask. Give me the grouping and the sales for a couple of key groupings, right? So maybe I want to filter for just this back to college and movie night, right? And group by it. So super common query, and here's how we solve it. So we run it in a couple steps. One step is just scanning that lookup table, pulling out all of the products and grouping, that sort of mapping of products and groupings that meet that grouping filter criteria. And then we can generate multiple queries and take multiple passes over the data, but one per grouping. And so at the top here, we will query for back to college. And the bottom one is a movie night. And you'll notice each has a different where clause that has an in list of products. This one's nice and simple and concise, but that in list can be hundreds, thousands, hundreds of thousands, in fact, and works really nicely. We run those queries in parallel, and then we can collate them back together into the answer that the user wanted. This is the advantage that we have with that middle API layer where we can put some of this logic. So unions, lookups, these give us the ability to do some cool stuff in terms of blending data around. So some other features maybe that we rely on to power this platform. We love the ability to do multiple different ways of ingesting data. So when we first started this, we settled on the Hadoop indexer, largely because we have some Hadoop expertise here. It seemed like the easy route to go initially. And so wrap all of our indexing into a custom tool that we have, an in-house tool here that allows users to move data from their source into this platform. And so with that wrapper, we can actually hide some of the complexity of ingesting data into Druid. Right, it'll generate ingestion specs. It'll take care of mapping your time series columns and everything else. As we evolved, we found that Hadoop indexer worked great, but for small data sets, became really slow. Right? There's just too much overhead with it. It lean on the native indexer for that. Right? So for data sets that are 100,000 rows or 500,000 rows, native indexer works really, really well here. We've also expanded on the Hadoop side to orc ingest, right? Some of the data sets as they lie are really ingestible. And so ingest orc data. And of course, right, one of the powers of Hadoop is Kafka index, a real-time index. And so we're seeing more and more demand for this now. And so a lot of our data sets now are coming in the on-demand fashion. Other features, super useful to be able to inspect and pre-flight a query. So we can use some of the cardinality aggregators to tell us what a query is likely to produce. And we can do it super fast. Right? We typically can get this answer back in 10, 20, 30 milliseconds. And that allows our processing engine and our query generation engine to make some really smart decisions around how to process that query. It's super important to us that time is sort of key to everything in Druid. Almost everything of interest, almost every question that a user would ask of a data set has some time element to it. Right? What were sales last week? How many guests were in our stores in the last month? Time's super important. Other things you can do with time, you can pass in this array of intervals, and so it's in pretty much any business, period over period comparison is really powerful, and the fact that we can pass in an array of intervals certainly helps. Another feature we lean on, there's an arbitrary granularity extension that allows us to simulate our internal fiscal calendar. So looks a little something like this, where you can just pass in an array of granularity intervals. And so when you want to say, summarize sales by fiscal month, Druid can do that for us. Some other key features, the metrics collection. This is super cool I think for anyone that was in the session this morning. Gian showed some query tuning and optimization techniques. And one of the questions that popped up was, how do we know, right? How can we run and explain? How do we know what happened? The Druid emits some metrics that you can configure into a Kafka topic and get almost a real-time view of query performance, data ingestion statistics, overall even cluster health. Really valuable, gives you tons of insight into how queries are performing. In fact, we found this so valuable, we adopted it for other parts of our stack. So our API layer, we emit the same types of events into it to be able to measure unique users, unique sort of user-led queries. It gives us tons of insight into the platform. Right? When combined with some of the other instrumentation you get out of things like a Kibana, things like a Grafana, we have all kinds of insight into how the platform's running. We lean really heavily on the JSON query language. Right? At the time that a lot of this platform was stood up, this is what was available as sort of the interface to Query Druid. And it's been super powerful. It gives us a lot of ways to express some complex things. We do take advantage of some of the estimation aggregators, and count distinct is always a tough problem. And so taking advantage of things like Data Sketch, starting to get more and more into percentiles, quantiles, binning, the types of things we can do with some of the native functionality of Druid. So these are some of the key features we use. It's probably not an exhaustive list. I would imagine I missed some other super important things, but this is what we use. And so as we start to spin down, one of the tenets we talked about really early on that we think was important was scalability. And so I wanted to just toss out some scalability numbers here. We see about 4 million queries run on this platform a day against Druid. 4 million is a sizable number, but actually what that is it's actually a fraction of the queries that our users ask. So that's 200 queries a second at peak, but we actually do, the platform itself offers a bit of a query cache layer in that offsets and sort of answers on behalf of target some commonly asked questions. The main principle here is save Druid for the important, interesting questions. And and you talk about scalability. We talked about responding to surges. Right? We know we need to handle much more demand. Right? In the near future, certainly could be looking at double or more of queries being run. Today, the platform services about 70,000 daily active users. And this is folks in the stores. This is folks in our distribution centers and in headquarters locations all the way on the other side of the planet. And the nice thing with this number is it's users from all over the organization. So there's folks in pretty much every pocket of the business that are using this platform. And then, as we said, we also want the data to be embeddable. So we've got at least 15 examples of back office or mobile applications that are taking data from Druid and surfacing it to those users. Like I said, we got about 3,500 data sources, probably approaching 3,600 as of this morning. And that's about 50 billion rows a day that we're loading. Loading and or reloading, reprocessing. All told, response times still stay reasonably good. So group by tends to be one of our most frequently run query types. We can typically see those on average in the 600 millisecond range. So a platform's getting tons of use. It's going to continue to grow, and there'll be a few things that we'll be adding as we scale this platform more. So where are we going with this platform? Gion's talk this morning was fantastic and very timely. We always need to push the envelope on performance. Right? There's Druid is magical and fast, but there are always a need to go a little bit faster. And so, a lot of what was talked about earlier today will incorporate and have actually been incorporating into the way we load data. We need to do some sort of workload management. Some of our queries are of the kind of slow variety. Scan billions and millions of rows and summarize 20 different metrics, group by something fine grained. These are expensive queries to run in Druid. On the other hand, we've got some that are lightning fast, right? Or sales from my location last week. All of that exists on the same platform, and we want to make sure that the slow stuff doesn't impact the big stuff or the fast stuff. We always want to offer users more functionality. We want them to be able to write more complex queries. And so this is taking advantage of things like window functions. Super common question people ask is, what do I do if I've got an order date and a ship date? We want to be able to represent that in data and allow users to query based on more than one timestamp. And we might take a poke at some Druid native joins, see what we can do with that. And then lastly, we'll push on this event style data, this analytics ready data. The union pattern that we talked about could be crazy good, right? Crazy useful if we could get almost all of our data sets to conform to a standard style, a standard structure. We'd love to be able to unlock more of that power to give users sort of a self-service blending capability. With that, we're at time. We'll wind it down and open it up for questions.
Jeremy, wonderful. Thank you very much. Round of applause from the UK. Very cool. Thank you. I have got lots of questions for you.
I was hoping so.
I think it was well, personally, I was so glad that you mentioned hierarchies, because I came from an MDM world prior to working with Druid, and it was nice to hear a good term again. So thank you for that. So we've got a series of questions. I'll start with a question about where you're actually running the platform. Are you using the Imply distribution? Are you using open source Druid? Are you self-managing that? What kind of hurdles did you expect, or did you have? How did you make the decision about where to deploy?
Yeah, that's an awesome question. So we are self-managed. So it's just the open source version of Druid. We've built a competency around running a lot of large clusters, right? We operate our own Hadoop cluster. We obviously Druid, and so managed by an internal on-prem team here that has gotten really good at managing hundreds of nodes in a kind of a well-automated fashion.
So quite a big team?
Would you say? Surprisingly, no, right? And this is where the automation comes in. If folks are interested, I certainly could provide more, and we can get you in touch with folks, but it's actually a really small team, a lightweight team that's taking care of our Druid cluster. They just do a really good job at it.
Well, you're going to have to give us another talk on how they do that. That would be brilliant. Thank you. So next question, what's your primary data visualization tool? So I noticed that you've got a React UI that you've built on the top. Are there other data visualization tools that people are using?
Yeah. So the primary one is our custom built one, and that's what it's in our React UI. It takes a lot of AM charts specific functionality and sort of wraps it around it. well, it wraps in charts in some of our own custom functionality and provides that. So almost anything from visualization tends to be from that library. And we have some custom just random HTML tables and a custom pivot-based solution. A pivot table-based solution, not to be confused with the product.
Terminology correct, yes, thank
you.
So I'm going to skip some of these questions, but as I said, we are going to come back to all of these in a follow-on blog post, so I apologize if I miss your question out. I've got a question about the security features like access control. How are you governing security on top of what you've built?
Yeah, another really good question. So if we toggle back to the architecture diagram, you'd notice that there was only one line in and out of Druid, besides the ingestion path. But it means that all queries to Druid come through our API layer. And so Druid by itself actually doesn't enforce any sort of ACL-like access. It requires authentication. So we do at least make sure that we know who you are when you run a query. But queries on Druid are actually only executed through the custom API. That custom API then can take care of mapping users to the data set objects that they want to be able to query, to the groups that they belong to potentially the role level security access that they might have to certain data sets. And so it's all embedded in that bit of logic. Druid by itself is authentication only so far.
I've certainly seen that as quite a common pattern where people are building basically the application logic essentially in an API layer above Druid. So that's interesting to hear that you've done that. Is that quite a complicated layer? Did that require a lot of investment to do that?
A fair amount, only because of the variety of security, right? So there's the ACL style security of can I see an object or not? There's the row level access. I can see this object, but I can only actually see a subset of the rows. So the variety there makes it slightly complex. In fact, we've actually taken it one step further to column level. I can see a data set, but there's certain metrics that we protect. Right, in an HR data set, maybe we want to protect things like gender, right? That might be useful.
Right.
So, yep, lots of different layers there. Individually, none of them are super complex. Together, there's just a lot that has to work together.
So I'm going to stay with this question about the API. There's a couple of questions about that. You're running multiple queries on the same data source simultaneously and aggregating that in the REST API. Is that right?
Correct. Yep.
And so the question is, have you tried doing a union all in order to get the same result within Druid? Did that just not work for you?
It's a good question. We could try it. I think, so one of the problems that we have is, so the example that we showed was limited to 2 groupings. It's possible to have hundreds of groupings, right? I think I saw one yesterday that had 3,300 different groupings, right? It might be possible to union all of them together. We'd have to benchmark that and see if that comes back any more efficiently than it would be to just run a whole bunch of queries in parallel and paste them together when we get back. It's an interesting suggestion.
Cool, thank you. I mean, well, it wasn't my suggestion.
Interesting suggestion from somebody.
Yeah, it was me. Yeah, thanks. You're combining these results, just to clarify this, because one of these questions, you're combining the results of these many select clauses that your bit of custom lookup code is doing. That's all happening within that REST API rather than inside Druid itself, right?
Yeah, correct.
Yeah, okay, cool. So there is a question here about the caching layer. It's something that I picked up on, something that you'd said as well, because Druid has its native caching. You've built a secondary cache layer above that, I guess, as well. What led you to that design decision? But then the actual question is, how did you build that? How did you integrate that into the overall architecture?
Yeah. So the decision, so we do have caching enabled in Druid, right? So we cache some at the broker level, we cache some in the historicals. So we do rely on Druid caching in some places. What we wanted to do was specifically address some of the really repetitive questions and make sure that we could answer those quickly. And so it's actually a dirt simple solution. We run the request through our query generation logic. And at the end of that, like right before we submit the query, we just take basically kind of a quick snapshot, right? A hash of the query we're about to run, and look up in a key value data store, right? Just say, hey, have we seen this query before? And if we have, we'll just pull a result that we got stored in that key value data store out and service that. If we haven't, clearly we'll run the query, and then we'll stuff it in our cache data store. Right? And the nice thing is it offloads all the work off Druid. And then because our query generation takes into account a whole bunch of things about the user running it, the security that people might have, it's a closed loop system, so we know when data sets get updated, and we know when we can invalidate those caches. It works out really well. So we can take a snapshot of that query, look it up. If a similar query comes in but not quite the same, it's a cache miss. You know, it's a kind of almost a stupid simple solution that's really elegant and works fantastic for us.
Yeah. Cool. Well, cool. Thank you for that. We had a couple of questions about deletion of data from within inside Druid. Is that something that you've had to deal with and handle well? How have you done that?
Yeah, so not a ton yet. So a couple different things here. So one option to delete data that when we give people sort of the self-service ability is overwrite with largely a null segment. Right? If I want to delete an old segment, just right, give me one null record and we'll overwrite that segment. That's sort of clunky. We do take advantage of the trying to remember the Druid terminology here, some of the kill tasks where we can actually set up almost retention guidelines and have the cluster manage that. We haven't exposed that in a self-service way yet. We're getting to that point. This is a platform that's been running for a few years now, and we're starting to bulge at the seams of maybe some old data that should be aging out of the system. And so we will get to that point. That's something that also probably belongs on our future roadmap, to give people the ability to say, only retain X amount of days, months, years of this data.
Right.
Yep.
Right. Cool. So I have one anonymous question that's come in, and it's this. You started to talk about this real-time data that you're kind of moving towards. How does the end user differ? How does it differ between people who are happy with the Hadoop-based ingestion stuff, but the end user who's demanding the real-time stuff?
Yeah, it's a good question. Anonymous, I can only assume I was one of the target folks that are tuned in right now. So real-time, like we said, part of the challenge with real-time is, do you have analytic ready data coming through in a stream? And so Target's maturing quickly in that space, and we're getting to the point that we can start running sales, for example, through a Kafka stream. We don't necessarily see a differentiation there. Users are looking for more and more actionable information, and some of that is just reduced latency in general. So yesterday's data is not quite as important anymore. One of the things we'd love to be able to set up is give people some more self-service capability to ingest real-time data. We're close. There is an automated way to do it, but it's an emerging spot in the platform.
Cool, thank you.
Yeah.
So I think we have time for one more question, and again, these will get answered in a follow-up blog. And it's an interesting one. I'd like to know this. Do you use Druid to support the front-end real-time queries from the target web page itself?
It's an awesome question. No, we do not. So someday maybe. Yeah, it's possible.
Why not, Jeremy? Why not? Well, we might be able to slip in another one here.
Let's do it.
It's a quick question about, well, it's a series of questions actually. People have been asking about how you're actually looking after the schema design. How are you taking care of schemas when they change? How are you looking after the actual data model?
Yeah. So some of that complexity gets wrapped up in our ingestion tools. So I made reference to this in-house ingestion tool that we use, and we use it for more than just ingesting to Greenfield. So it's a tool that folks are used to. The tool will allow a certain amount of schema evolution, but also is aware of when you're potentially going to introduce a schema that's just simply not compatible. In that case, it will almost force you into a truncate and reload type of path. one of the cool things about Druid is the ability to, introduce schemas that aren't exactly the same, right? We can add new attributes without disturbing old data. And so that kind of stuff, it just flows through seamlessly. When we get to an incompatible schema, we do alert the user and force them into some choices on how to accommodate that.
Cool, thank you. Well, I was very happy to hear you speak, Jeremy. Thank you very much, very insightful. And thank you to everybody who's asked questions of your participation today. A link to all of the slides and recordings that you've seen will follow. We'd love to hear your story about using Druid as well. So please send us an email, community@imply.io, and we can also let you know more about the future programs that are planned across the world. There's more to come today. Our fourth session at the top of the hour is from Nicholas Ngorok, who is the engineering manager at Twitch. So all get your PlayStations ready. He'll be walking us through self-service analytics at Twitch. So I look forward to meeting you all again in about 14 minutes. Excellent. Thank you, everybody. Goodbye.